Hey guys, this is Madan for CG Tunes Plus, and good to see you after a long time. And today we'll be seeing on how to create some realistic good-looking trees in Speed Tree, and later on we'll see on how to import these trees into UDK and generating huge amount of trees. So let's get started. First, this is the overall layout of Speed Tree. It has got the object properties window where you can set the different attributes that control how your tree will look, and this is the like help window, which allows you to see what each property does. For example, if you want to know what this role does, just click on it and it'll tell you on the description of the attribute. And this is the curves editor. This allows you to control the attribute according to the length of the tree, that is from 0 point to the maximum length where this attribute is at the specified point. And this is the asset browser, much similar to the content browser that you see in UDK. If you wish to import any materials or meshes into SpeedTree, then you do so by using this asset browser. First you create the material in the asset browser, and then choose the material in the object properties window. And this is the most important window in SpeedTree, the generations window. It allows you to specify how your final model will look like the various parts of the tree, like the branches, leaves, and how they are distributed in the tree. One of the important properties in the generation of the trees. So before creating the speed tree, let me tell you what speed tree generally is. Speed tree is generally a tree modeling program that allows you to generate trees um, randomly, like truly procedural trees, but each and every tree will obey the different properties that you give over here in the properties tab, and they'll be generally different, like procedurally generated trees. These trees are different from what you create in 3ds Max, because in 3ds Max you just use a set of extrusion techniques and edge loop techniques to create a tree, and you just get a single tree. But in UDK you just set the properties on how the tree will look like, and each time you give a different seed value, you'll get truly different trees each time. So that's what speed tree is, and let's get started. First we'll learn on the different parameters that are inside speed tree, and then we'll see on how to create some real life trees in speed tree, and later on we'll import those trees into UDK and just play a simple level from there. So first step to generate a tree is the generations tab. Here you can see that there is a tree node present over here. Well, this is the main node for a tree. This tree node generally is the circle that you see over here. This is the basis or the foundation of a tree. It has got some different values, like the radius that controls the radius of the circle. The circle is generally the area where the trees will get generated. The trees will not be generated outside the circle. So that's what the radius does. And sync is the height at which the trees are generated. So a value of 5 will sync the trees bottom by 5 units, while -5 raises the tree by 5 units. We'll keep that at 0. And a roll is generally the orientation of this trees or alignment of this trees. So it takes floating point values from 0 to 1. For example, if you put 0.3, it's like rotated 0.3 units as such. And level of detail is an important term as far as games are considered, but you don't hear level of detail much in pre-rendering packages like 3ds Max and Maya, because in real-time rendering applications like games, each and every frame has to be rendered in less than 20 to 15 milliseconds. In that time, rendering a huge amount of polygons is very difficult. So what level of detail does is, when you are really close to the trees, it just renders the entire tree as it is, but as you go farther away from the tree, it procedurally removes the amount of detail or the amount of polygons in the tree, so that this brings down the polygon count and reduces the bandwidth between the CPU and the graphic card that is being used, and hence speeds up the rendering process, giving much more time for other uh, let's say other parts of the games, like artificial intelligence, physics, etc. And that's what level of detail does. And these parameters we'll see when we are exporting the tree. And the leaf collision is an important attribute that allows you to specify how the leaves are spread in the trees. It generally allows you to um, put a less number of polygons and yet get the same amount of denseness that you get from a more denser tree that has more amount of leaves in it. And degradation is like speeding up the viewport, because when you have some heavy polygon trees, then it makes your viewport a bit sluggish. So that's where degradation comes into play. It just reduces the amount of detail that you get in the tree, so that the viewport is a bit sped up. And interactive degradation, same as degradation, but this comes into play only when you're rotating or panning the screen. It switches to a wireline display that greatly improves the panning on rotating speed. And physics, it generally deals with the physics attributes like the wind and collision attributes, etc. First let's generate a trunk for the tree. So the method to generate a trunk is just select the tree and click this add to selected icon, and go to trunks, and here you can see that there are 5 different trunks. Well, all these are the same template. Each one of them have different properties that are assigned to them at default, that is while creating them. So a standard RT can also be made to look like a Stalks RT by varying the parameters that you get in the object properties window. So normally I would go and generate a standard RT, because all the trunks are the same and you can get the same amount of control that you get from other RTs from standard RT. So it has some huge amount of settings. I'll not be going into each and every one of the settings, because all the settings are pretty straightforward. And also, if you don't know about some of the settings, you just can always click on the setting and look at the help window down. It tells you what that attribute does. So let's go to the top, and here you can see that we've got a generations tab, and this has to do with the generation of the trees, the this is the foundation of the tree. It deals with the number of trees that are getting generated, which is defined by the frequency. So the more the frequency, the more the number of trees, like that. So 5, if you put a frequency of 5 over here, then you can see that 5 trunks are being generated from the generation window. But that is not the case in case of relative, because relative is it depends on other attributes like the size of the um, tree node and the length and radius of the trees, and generates trees according to the other attributes. So normally I would select absolute, because it gives me a more finer control of the trees. Let's select this to 1, and this first and last value specify where the trees are distributed in the circle. The first is the lowest point in the circle, that is the center of the center of the circle, where it is 0, and the edge where it is 1. So the first value specifies the lowest point at this circle where the tree can be generated. So right now it is set as 0. If you put 0.5 over here, uh, any place less than 50% of the circle, the tree will not be generated. It will only be generated from zero point 0.5 to 1. And if you want the tree to be generated only at exactly zero point 0.5 distance from the center, then just put zero point 0.5 for both first and last, and that way each time you select randomize, it will be generated just at that zero point 0.5 distance from that circle. That's what first and last values does. And size scalar, it is the overall control of the size of the tree. So zero point 0.1 means 0.1% of the actual tree, and 1.5 means 1.5 times the actual tree. Normally we can leave that at 1. And degradation style, whether the tree has to be degraded when we rotate or not, that's what degradation does. And orientation, it has to do with balancing this tree when other nodes are connected to this. So this gives some realistic looking trees that are self-balanced. And there's nothing much useful attributes that you can see from this generations tab apart from these set of values. And forces allows you to add some different forces like radial forces or twist forces to the trees to get some really good looking trees. And the geometry tab allows you to specify whether the viewport displays the branches, caps, etc. For example, if you tick the branches, then the entire trunk of the tree will not be displayed. That's what the geometry type do. And the random seed allows you to generate different random trees from the parameters that you have given. And segments, this is the place where the real controlling of the tree shape starts. The segments, it is the amount of detail that is added to the trees. Let's switch to the wireframe mode to see that effect. So as you can see over here, the tree has a lot amount of trees than what you would get from a game model. So to reduce that, bring down the multiplier. Let's bring that down to 0.4, and now you can see that there's much lesser detail on the trees. Well, the tree has become into a triangle shape or square shape. That's not what we want, so let's increase the multiplier to 0.6, and let's select this to absolute. So in absolute, the length segments are added to the trees just randomly, but in length relative, they are added to the places where there's more curvature, so that you get a more curved surface out of the tree. And that's what the style does. And accuracy, it is it increases the amount of curviness in the trees. So 50 increases the curviness a lot more. Let's set that to 25 by default. Length is the length of the tree along which the segments are added. So the lesser the length, the lesser the number of segments, as you can see, and more the length, the more the number of segments. That's what the length attribute does. Let's bring that down to 8 or 13, so that it gives a more nicer tree. And optimization, the higher the optimization, the more optimized the tree will be, and the lesser the optimization, the less optimized the tree will be. So a value of 1 optimize the tree so much that you lose the detail in the tree. So optimal value is 0.1. It gives much better optimization. And cap, each tree has a cap at its tip. So if you go closer, you can see that what this cap attribute does, it defines the number of details in the gap segment of the tree. So you can see that over there. Let's decrease the value to 1. And weld, it's not much of a useful attribute. It just increases the number of segments composing a weld, that is the places where other branches are coming out of the tree, like the secondary branches. And the spine length is the actual length of the tree, so higher the spine length, the more height the tree will be. Let's set that to 25, and this spine length has a variation of 10, so it can lie anywhere between uh, 15 and 35. So you can see that from the variation of the length. If you want it to be a constant height, just set it to 0, and you just get a constant height for the trees. And sometimes you can see that some trees are shorter. That's because the branches are being broken according to the settings that are given here. These are called broken trees. So that's the uh, uh, thing that comes into play when the trees get shorter. If you don't want to get broken trees, then you can always set that to 0. Let's see how we can do that later. So let's set the length to 25 and increase the randomness to 5, like that. And the next attribute, that is the start angle, defines the inclination of the trees with respect to the ground. Well, this is the place where the let's see, where's that? Just a second. Yeah, orientation. This is a place where the alignment comes into play. So generally uh, the alignment specifies the point where this dot should occur, and the start angle inclines the tree as given by the start angle towards the dot. So incline the tree to 45 degrees. I'm sorry, it takes values from 0 to 1, so 0.45 would be the right value. And you can see that it's inclined 0.45%, and 0.9 will increase the inclination. So 0 is a perfectly erect tree, and 1 is a perfectly erect tree that is facing the bottom. And this gives a randomness to the start angle. Let's set that to 0. And as far as the other settings goes, all are just uh, straightforward. One important setting is this bifurcation. This tells whether the tree has to just split along its length. So a chance of 0 says that the tree has 0% of bifurcation, and chance of 1 says that the tree always bifurcates. And this gives the randomness value. And the spot specifies where the bifurcation occurs along the length of the tree. 0.45 says that the bifurcation occurs at 45% from the bottom. 0.1 says that it occurs 0.1% from, I'm sorry, 10% from the bottom. So let's bring that to 0.4 or something like that. And let's increase the spot to 0.5. Let's decrease the chances of bifurcation even more, because I don't want really bifurcated trees. And that's what bifurcation does. And the angle specifies the angle between the two branches that are bifurcated. And other settings are the same, and this gives the radius of the branch. 4 gives a thicker branch, and 1 gives a thinner branch. So let's set that to 1.5, which is the default value. And other settings are pretty straightforward. This specifies the materials that are applied to the trees, and the displacement map, and level of detail comes over here, and wind settings comes over here. So let's just delete the tree, and delete this tree, and build a real life pine tree. Let's see how to build a pine tree from 3ds Max. Well, this pine tree is going to be a truly procedural pine tree that is truly random each time we generate it. Let's get started. So here you can see a reference image of a pine tree. So let's build some trees based on this reference. So let's get started first by adding a trunk, a standard RT, and this is going to be a game optimized model, so it's going to be optimized for games. So first let's set some basic settings, like the segments multiplier. Let's bring that to 0.4, and set the style to length width relative so that we get some nice rounded edges over here. And I think we can decrease the uh, detail even more. Let's select the multiplier to 0.3, and yeah, that will do the trick. And let's come into the radius. Yeah, here it is. And here you can see that the radius has a graph over here. What this graph means is the left side denotes the bottom of the tree and the right side denotes the tip of the tree. So as you can see, the right side has more y value and the left side has lesser y value. That's why the tree is getting pointed as it goes up. So let's decrease this y value at the base and increase it slightly, just a bit, so that it's just a bit more evened out, like that. Yeah, that'll do the trick. And next up, let's specify the length of the tree. Okay, 25 plus or minus 10. Let's set that to plus or minus 5. And another attribute is pine trees don't generally bifurcate along its length. So let's make sure that the bifurcation chance is 0 so that the tree doesn't split. And well, the break style, let's set it to random so that we get some good breakings of the trees, which gives some naturally destructive trees or destructed trees. And next step is building the secondary branches. So let's select the trunk and go to branches and build a level 1 standard, build a level 1 pine RT, like that. And let's modify some of the settings of this secondary branches. Okay, here the first and last value specifies the length of the trees. 0.5 value for the first tells that it must start from 0.5 distance from the bottom of the tree, proportional to its length. So that's pretty much good. And frequency, let's increase that to 30 just to give it a more denser look. And let's come down to the length of the trees, yeah, over here, and let's modify this. We want the pine tree to be secondary branches of the pine tree to be more longer at the bottom and shorter as it goes up. So let's increase the y value over here, and bring it down over here, like that. And also let's modify the start angle to 0.6 or something like that, and that looks nice. And let's set the disturbance to 0.1 so that the trees are less distorted. And Let's increase the bifurcation chances to 0.5, and I think we can increase the length of the trees a bit. I'm sorry. Let's select the trunk and increase its length to something like 35. Okay, and and I think that's it. Okay, one important thing is let's modify the segments. Let's go into wireframe mode and set the multiplier to 0.5, just to reduce the amount of details in this, cause we don't want that amount of difference or detail in the secondary branches, so that would be good. Let's select length and width relative, and okay, that's it. Now let's add some more secondary branches to it by selecting the level 1 branches and adding level 2 pine RT, and let's come over here and let's decrease the first to 0, and let's go to the segments and decrease the multiplier to 0.2, or let's bring it down even more to 0.1, and you can see that the tree does not have secondary branches over here. Well, that's because of the let's see, pruning over here. So let's select that and just make that graph like that, and bring it down at the tip like that, so that does the trick. And I think you can add a little more number of level 1 branches by increasing the frequency to something like 38. Okay, and next thing, let's come down and okay, let's now add leaves to this. So let's select the level 2 branches and go to leaves and select standard RT. So you can see that there are hell a lot of leaves over here. So let's decrease the frequency to 1. Let's select 1.5, something like that, and let's apply some materials to these trees. So the method to do that is by clicking the add button over here, and let's select add and add a bark material. Oh, I don't know why this has happened. So let me go ahead and restart speed tree quickly. Okay, so here I've gone ahead and restored the scene. uh, so let's add some materials to it. Click on this plus or minus sign and click add, and select bark, and next is leaves, and select OK. Now you have two materials in the asset browser. Let's select bark and come down, and let's close this window over here, and first select the diffuse channel, and let's we have to set the image for the bark over here. So let's select the pine textures. So here we have the pine bark texture. Let's open it, and let's go to the normal map and select the normal map for this. And now we have imported the bark texture or bark material into the asset browser. Next, oh, I've made a mistake. Let's just rename this as bark, and rename this as leaves. Okay, so we have now imported the bark texture, and now let's select leaves and do the same for the leaf texture. Import the normal map, and we also have a specular map for the leaves, so let's do that now. And now to import these materials onto our trees, let's make sure that it's in the lit shadowed textured mode, and select the trunk, come down to the materials, expand this, and select the material to bark, and we can also select the cap material to bark, like that. So after setting the bark material, you can get a warning over here that the tree model is not valid for use with the UDK, because in UDK you can't select the cap texture inside the content browser. So let's just ignore this, because we're not going to have the cap material inside UDK. It's just going to be the entire tree. And next, let's select the secondary branches, expand the materials, and select bark, and select the next set of secondary branches, come down and select bark for this. And now for the leaves, let's select the leaves, go up to the here type, and set the material to leaves. So you can see here that we have got the leaves, but they are a bit too less, so let's select the secondary branches over here and increase the frequency to 40. And next, we want the leaves to be a little bit spread apart, so let's go to the leaf collision mode and select spread, so that we get a more spread out tree. And let's tweak the branches a little bit more. Let's select the start angle to 0.7, or I'm sorry, 0.4, and that's it. Let's just so if you see here, there are no branches over here, so to edit the individual nodes and bring them to this place, all you have to do is go into node editing mode and select this node, just make a rotation, that's it. So that just spread them so that they are a bit more evened out, like that. And let's select the leaves. Let's go out of node editing mode first, select the leaves, and just bring down the pruning a little bit more. Let's just click on insert point over here, like that. And I think we can bring down the length of the branches just a bit, so let's select 10, like that. And that's it, you've got a pretty nice pine tree over here. So each time you click randomize, you get a different pine tree with different arrangement. So that's the cool feature of speed tree. In the next tutorial, we'll be seeing on how to export this model and importing them into a speed tree, I'm sorry, UDK. So let's stop this tutorial over here, and we'll continue in the next part.